Well, good evening, boys and girls. I hope you're having a great night so far. Huh, this is weird. This thing looks a little not. Huh, maybe I didn't hear that. Sleep last night. Anyway, I'm going to talk to you a little bit about proportions, and what you're going to do is then fill out a graphic organizer based on proportions. And tomorrow in class, we are going to do a hands-on activity related to the real world, dealing with unit rates, ratios, and proportions. So a proportion is an equation stating that two ratios are equivalent, so very, very similar to each other. So here's an example. When you work towards some sort of goal, your success is usually proportional to the amount of work you put in. So for example, if you work really, really hard in school or some sort of goal that you're achieving, most likely you will succeed because you work so hard. They're proportional to each other. Here's an example. It says if the number of reps that I can do at the gym is directly proportional to people I think are watching me. So for example, if I'm at the gym and I do a lot of reps, I'm pretty sure a lot of people that are watching me. But if I do like 2 reps at the gym, I'm sure not many people are watching me. So there's something kind of funny to think about. In this example here, we have a puppy and then a grown-up dog. So the size of the head of the dog is proportional to its body, whereas again, the size of the head of the older dog is proportional to the body. So they grow at what's called a constant rate of each other. So we're going to watch a video, and then you're going to fill out a graphic organizer. The video will help dive in a little bit more into what a proportion is.
Fast charts. Proportional relationships. Two quantities are said to be directly proportional if they vary at the same rate. Meet Carl. He's mixing punch for a party. The recipe calls for 2 cups of juice for every cup of ginger ale. If he doubles his recipe, meaning he multiplies it by 2 to start with 4 cups of juice, he'll need 2 cups of ginger ale to keep the ratio of juice to ginger ale 2 to 1. If he triples his recipe, he'll need 3 cups of ginger ale. All the ratios of juice to ginger ale are equivalent. They all simplify to 2 to 1. This means that the relationship between the 2 quantities of juice and ginger ale are directly proportional.
So just a quick review here as I stop the video. We talked about ratios in class. There's a few ways to write a ratio, 2 to 1 with a colon, and as a fraction as well. And these are all equivalent because they reduce to 2 over 1. They're proportional to each other.
Another way to see proportions is with a graph. We can plot 2 cups of juice and 1 cup of ginger ale like this. We can show how Carl doubles and triples the original recipe like this. A straight line through the data points shows a direct proportional relationship, as long as the line goes through the origin. But what happens when the line doesn't begin at the origin? Check out this graph. The line starts at 3 cups of ginger ale, so we would need to add 3 to all our previous answers on the table. But if we do that, the ratio of juice to ginger ale is no longer constant. The 2 quantities don't increase at the same rate. This is not direct proportionality, and Carl's punch won't taste so great. Ratios, tables, and graphs can help us identify proportional relationships and make awesome punch.
Alright, so there's just a little video to help you. If you need to rewind and play it again, you may do so. So we're going to fill out the palm tree graphic organizer, and you'll see in a minute to solve for proportions why it's called the palm tree method. So for example, let's talk about Carl's party. Say if he needed 60 cups of juice and 100 cups of ginger ale, those were 2 proportional, made a good kind of punch for a party. So for example, what if he only had 80 cups of ginger ale? How many cups of juice will he need for the parties. Maybe it's not as big. So this is how you solve for proportion, and we're going to work on this a little bit more tomorrow in class. So what I want you to do is circle diagonally the 60 and the 80, and then the 100 and the X. Then I want you to circle the equal sign. So here, it kind of looks like a palm tree. Now, to solve, you're going to multiply diagonally. So I'm going to multiply 60 times 80. Bear with me at the handwriting again. And then 100 times x. And 100 times x, or anything times x, is just, in this case, 100x. I don't need to put the multiplication sign between them, because it's already assumed that they're being multiplied when they're next to each other. And if we put a multiplication symbol here, we might get confused between x and the multiplication symbol. So I'm going to take out my calculator and multiply 60 times 80, which is 4,800. Again, and I got that because I'm multiplying diagonally. 60 times 80. 60 times 80, which is 4,800. On this side, the equal sign. The other side, the equal sign is 100 times x, which is just 100x. Now, going back to solving equations, in order to solve for x, we need to use the inverse. 100 is being multiplied by x. So in order to get x by itself to solve for how many cups of juice I might need for this party, the opposite of multiplication is division. So what I do to one side, I have to do to the other side. My 100s cancel out, so I'm left with x is equal to 4,800 divided by 100. One trick I can do here, if I cancel out these two zeros, I'm left with 48 over 1. This is also the same as 48. Now to double check that property, I'm going to take 4,800 divided by 100, and I get 48. That means in order to be proportional to 60 cups of ginger ale to 100 cups, 60 cups of juice to 100 cups of ginger ale, I could also have 48 cups of juice to 80 cups of ginger ale. It'll taste the same, it'll just be a smaller amount. Alright, we are going to reinforce this concept in class tomorrow a little bit more. I hope you have a great night, everyone, and I will see you in class tomorrow. What's that, Carl? You want some pen? Alright, sounds good. I'll bring some over.